Today what we're going to be talking about is we're going to talk about something called marginal cost and revenue and then profit. Now, uh, I'm sure you guys learned about the marginal cost and marginal revenue and marginal profit earlier in other classes. But today what we're going to be doing is we're going to be doing this one in uh, a mathematical perspective. You know, so uh, if X is the number of the units of the product produced in some time whatever some time interval, and let us say total cost is this, then derivative of that is marginal cost. So essentially, what's happening is this. Uh, let us say total cost. I have some function. We're going to look at a few examples, but let us say we have total cost of making something. We have some sort of function that represents the total cost, and then a marginal cost will be how much more it will take one more unit at a time. You know. So essentially, if I have to give you context, what's going to be happening is this. So let us say I have a company, and then I realize the pattern of my cost. So I was able to establish the cost function, and then revenue. I can calculate the revenue, and every item that I sell, I can get this much money. Okay, and then therefore I should be able to find the profit, right? So in fact, I was able to figure out, looking at the past practices, I was able to figure out the total cost. How much does it cost me? And then set it up as a function. And then uh, total revenue, I was able to figure that out as well. You know, and then therefore I should be able to calculate the total profit. Then, as a business, what we have to always ask ourselves is, okay, I'm making this much profit, or I am losing this much money. Depends upon context. Right now, I'm sure many people are struggling. But so let us say I'm lucky enough to make a little bit of profit. And my next question is this: Hey, should I increase my production level? Sometimes, in fact, when you increase the production level, it will be beneficial. It will bring in more profit. But sometimes, only because you're increasing the production level, it doesn't mean that you will be able to uh, profit more. So you're at that moment where should I increase it or not? And then if I have to increase my production level, how much should I increase? So those are the kind of questions which we can have as a director or a manager or somebody who's in the decision making uh, places. So that's where the marginal cost comes in. So marginal cost is if I have to make one more unit of the product, how much will it cost? And marginal revenue is if I have to sell that one more value, then what would be my revenue that I'll be getting? Change in the revenue, right? And then when I subtract those two, that simply becomes my marginal profit, meaning what would be the profit if I had to make one more unit and then sell that one. So that's the so by looking at the marginal profit, you can kind of tell, oh, wait a minute, should I go ahead with increasing my production level or not? You can make that kind of decision, right? So let's look at a couple of examples here. First example would have been this one. So let us say a company manufactures a fuel tank for the car, and then their weekly cost in dollars in producing X tanks is given by this one. So cost will be this much, 10,000 plus 90X minus this much. Okay. So generally 10,000 will be the like basic structure, that you have to spend no matter how many things you are producing. Like it can be rent, right? It can be basic salary that you have to pay no matter what, as an example. And then maybe 90x would have been like what you call it, some sort of material. If you make what you call it, each one cost $90 per put on $90 per making one thing. But this might be the benefit of producing, the last portion is benefit of producing large, larger quantity. So if I make like 10 instead of 1, then because of the efficiency, I'll be able to uh, reduce my cost a little bit. So something like that, right? That's essentially what we're looking at. And the question is, I'll find the marginal cost. So what's the marginal cost here? Marginal cost is simply the derivative of the cost function. So C prime of x, this disappears, and then here becomes 90. Derivative of 90x is 90, right? And then this one is minus 0.05. I'm going to leave that alone. And what's the derivative of x squared? 2 comes to the front, so we have 2x. So that's what I have. So if I were to simplify it, I'd end up getting 90x. It's not 90x actually. It would be 90 minus 0.1x. So that would be my marginal cost. So as you can see, more I make, my marginal cost will go down based upon this model. So find the marginal cost at the production level of 500 tanks per week. So then that means part B is simply telling you C prime of 500. So C prime of 500 in this case would have been, oops, sorry, 1 second. All right, so C prime of 500 is, I'm just going to plug in 500 in place of x's. So we get 90 minus 0.1 times 500. So this becomes 90 minus what? 50, which is equal to 40. So what does it mean by this 40? This 40 basically means I've been making 500 tanks per week. So part C is I've been making 500 tanks per week, but if I were to make 501 tank, so if I make one more tank, right? If I make one more tank, what would be the cost for me? So I've been making 500 tanks, but if I were to make one more tank per week at that time, then it would cost me $40 more to produce it. Right? It will make $40 to produce this. So in fact, what's going to be happening is this. So if I have to say something like this, it will cost. Let me just reduce this one on size. $40 more, $40 more to produce one more tank at this level of production of 500 per week. Okay, so that's basically what's happening. So of course, I mean, because of the efficiency of the the factory or the manufacturing system, if I make one more tank at this location at the level of 100 will be different from at the level of 500. And in this case, at the level of 500, I've been making when I want to produce one more whatchamacallit tank, it would cost me $40 more. Okay, now part D is find the exact cost. So instead of using the calculus to estimate, they want you to actually figure out finding the exact cost of making 500 first item. So let's try to do that. If I were to do that, then how am I going to get in? Part D, that means to produce exactly the cost of 500 first item, that means cost of making 501 minus cost of making 500. So if I were to do this, then that will get me exactly how much it will cost me to make the one more item at the level. So let's see what we can do. C sub 501 is, in this case, I'm just going to plug in 501 here. 10,000 plus 90 times 501, and then minus 0.05, 501 square. Okay, and then that's the first one, minus 10,000 plus 90 times 500 minus 0.05 times 500 square. So I gotta calculate these two things and then subtract them. So I mean, I don't think I can do this one in my head. So what I'm going to do is I'm gonna take out my calculator. Alrighty. Okay, so in order for me to do that, I can type up everything onto this screen. You know, it is possible for me to type everything onto my screen here, but it might be too chaotic for me to calculate. So what I'm going to do is this. I'm gonna say I'm gonna put in the functions in y equals section. Okay. Once again, I got to y equals section by click on y equals. Okay, once again, this was my home screen. But if you click on y equals, then it gives me the function. You know, where place where I can type in the function. A function was 10,000 plus 90x minus 0.05 x squared. Okay, that's what I have. Now, what you can do is you can click what you call it and then you can go back out, right? And now what I want to do is I want to have y sub 1 and then 50. I want to plug in 501 and I want to plug in 500. The way that I can do this I can retrieve y sub 1. How? I can press alpha trace. Alpha trace gets me this option. And then number 1, y sub 1, open parentheses 501. Okay? And then minus alpha trace y sub 1 right here, which is number 1, open parentheses, and 500. Okay, and then press enter, and that's my answer. So in fact,
Amazing.
yeah, your calculator can do many things, right? Now, but I'm gonna try to give you the otherwise what you wanna do is you wanna type everything in, which is somewhat ugly, you know. So let me just put this one into the screen. What I typed in. So you get to realize that the exact cost to produce. So what I can do is this is my 83 actually TI 83 calculator, but the TI 83 emulator actually 84. But let me try to show you another way to do this one very soon. Okay, how about that? So my answer ended up being 39 0.95. So $39.95. So in the exact, when you actually calculate the exact cost to produce one more item at the level of production of 500 per week, it will cost exactly $39.95. But as you can see, my calculation is somewhat tedious and ugly, you know. But when you use calculus, guess what? You can relatively able to get pretty good estimate. And then uh, what's going to be happening is it's going to be uh, what do I say? It's going to be relatively quick, you know. So that's one thing that which you can do. All right, now, so that was part. But somebody asked me, what if you don't have this? I mean, you actually have this font, but let me try to tell you how else you can do it with the 83. With 83, first you have to type this one in. Okay, you still have to type this one in. All right. Once you type this one in, you have to go back to quit, and I'm gonna try to get the same thing. The way which you can get it is this. Go to vars. So I'm gonna try to go through this one step by step. You please stop me if you get lost. Okay, right at the moment. So after you type in the function in y equals, this is true for 83 as well, or 82 even. And then second quit to come to the home screen. And what you can do is press vars. Vars is right underneath of these arrows. And vars are the basically variables. Okay, it gives you different kind of variables. And then what I need you to do is, you see the y vars, the middle y vars. Go to y vars. Go to y vars, and then the function, the first one. Press enter on the function. Then it gives you the y sub 1 to the y sub, whatever. So, and then what you need to do is, y sub 1 is where we store the function. So press enter, y sub 1, open parentheses, 501, close parentheses. So it just takes you a few more buttons if you don't have the font that I have. Then next one is what? Go to the vars, right, of vars, y vars, that's y variable, and function number 1, and we stored our stuff in y sub 1, and open parentheses 500, and press enter. Boom, there it goes. So you can still get the same answer, but you just have a couple more buttons to press. Okay. All right. So that's basically what's happening. Now, then what I'm going to do is this. I want you to do first of all, I want you to look at what we have done here. All right. So we were able to find the derivative and then plug it in and so forth and so on. Now, uh, there's another question which you can do as a practice. How about this? So I try to do the double screen for you. But in the becomes a little bit smaller, but okay, I make it as big as possible. All right. So here it is. Can you try to do this one yourself? Let me try to get you about how about 7 minutes for you to work on this one so that you can get it. All right. Interestingly, my computer is a little bit slow. Okay. 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 So I'm going to give you about 7 minutes. Why don't you try to look into this one? We're gonna get started soon. Righty. How's it going, guys? Is it okay? Or is it like
Yeah,
confusing a little bit?
that's good.
It's good. All right. I just wait a couple more minutes and get started slowly. All righty. So I'm gonna get going quickly on this one. So how everything would have turned out. So here, find the marginal cost function. I just have to take the derivative. So C prime of x. 50,000 disappears. We have 600. And here minus 0.75 times 2x. But when you simplify, what this one becomes is 600 minus 1.5x. So that's what we end up getting. So find the marginal cost at the production level of 200. Then B will be equal to C prime of 200. Then we get 600 minus 1.5 and times 200. That's equal to 300, I believe. And C basically means it will cost $300. It will cost $300 to produce one more transmission if you're already making 200 transmissions at the time, right? So that's the idea. It will cost $200 to produce one more transmission at 200 per week production level.
200 or 300?
200. This one was on 200 level. Oh no,
Can you
actually, yeah,
explain?
No, dollars.
yeah.
$200 or $300?
Oh, okay.
300. Sorry, thank you. I misread it. Okay.
Sorry, no, I just making sure.
Thank you. Level. Yeah. So it will cost $300 to produce one more transmission when you're already making 200 per week. Yeah. Thank you. All right. So that's basically what's happening, right? What's the exact cost of producing 201st transmission? So this one we're gonna just do the calculation, and then of course we're gonna just borrow our calculator functionality so that it'll be a bit easier for us to do it. So in fact, it's gonna be C of 201 minus C of 200. That's what I want to do. So then first, what I'm going to do is I'm going to type in this function onto my calculator. Okay? Okay, so I'm going to go for y equals, and I'm going to clear that. I believe it was 60,000. And then plus, oh no, 50,000. I keep on getting numbers mixed up. 50,000. And then 600 x minus 0.75 x squared. So that's what I have. And then all right, so that's what I'm plugging in. And I'm gonna do second quit, and I'm gonna do something similar. Now, if I want to be lazy, guess what? I can go on top and click on it. Then it just copies the same expression one more time. This time, y sub 1 is not my old function, but the function that I just typed it in. You know, you can do that. But if you couldn't do that from your calculator, you just have to go through this one more time. Vars, y vars, function, and y sub 1. And it was what, 201 minus. Same thing, vars, y vars, and function, and y sub 1. That's where we type in the function, and then 200. And then it gets us 299.25. So according to the exact calculation, it would have cost us 299.25 0.25. That would be the exact cost to produce one more transmission at this time. But you can see that without this much of calculation, you can do that quite simply using the marginal cost function, right? All right, then let's look at this idea, marginal cost and exact cost. So one thing that which we get to realize is this: if C sub x is the total cost of the producing the item, which we just have done so far, marginal cost function approximates the exact cost of the producing the next item, right? That's is essentially what they're talking about, and then that's what I explained it earlier. So, uh, in fact, so this is the same kind of question that we've been doing so far. So what I'm going to do is I'm going to skip this question and I'm just going to ask you to do, actually, you know what? I'm just going to ask you to do this question as a practice. How about that? And I will give you, uh, I will give you about uh, 5 minutes for you to do this one. All right. All right, I'm gonna get started very soon. All right, so I'm gonna get going little by little. First, I want you to find the exact cost. How do you find the exact cost? All right, exact cost in this case, A, is C sub 121 minus C sub 120. Of course, because we have calculator, it's a bit easier for you to find this one. Uh, but actually, guess what I'm going to do? Why don't I do this question entirely using the calculator? How about that? You know, uh, so that you have the options to do this one by hand and by using the calculator. So the way that I can do this one, as we have done it earlier, I'm gonna put down y equals. Oops, no, not that. No, y equals, and then the function is 10,150, and then okay, so 10,000 plus 150x minus zero point 0.2 x squared. I think it was this. Yeah. So that was the function that we typed it in. And then what I need to do is I need to type in 121 and 120 and then subtract it. So here I get second quit vars y vars function and y sub 1. All right, 121 minus vars y vars function 1. All right, open 120. So my exact value is 101.8. So at this production level, it will cost $101.80 more to produce one more bicycle at the time. Uh, but using the marginal cost, so to produce 121 bicycle, so that means that's A. B, what I want to do is C prime of 121. That's essentially what I'm looking for. C prime. I mean C prime of not 121. Sorry, C prime of 120 because 120 is at the time when I'm at the time 120 production level. What would be the next one? So C prime of 120. All right, I can do this one using the calculator. All right, so let me share with you how you can do that. So what you can do is go to math right over here under the green alpha button, math. Whether you have 84 or 83, it's going to be the same. Press math. And then if you to go for n the red. So if you have 84, I have a new font on that calculator, so it's a bit easier for me to type it in. So number 8, then it kind of does all these things for you. So I can type in x, and then y sub 1 here is what? I can type it in as vars, y vars function, y sub 1. That's the function that I was looking at. And then what's the value of x that I'm plugging in? It's 120. How about that? Boom. There it goes. Look at this. It gets you 102. Not bad. Not bad at all. Right? Not bad at all.
You're literally blowing my mind right now. This is crazy.
Yeah. Yeah. I mean, technology has been, advanced so much, and then
No, like seriously, I've had a calculator. I have to thank you so much and just stop you because like every other I've had a TI-84 like my whole college career and nobody's ever showed you this, you know? This is
yeah.
crazy. Thank
Thanks.
you.
Thanks. Thank you. Thank you. I mean, uh, when I was picking the topic of math, one of the reasons is because we can be lazy. We could write less and then get more out of it, right? I guess is that engineering? Engineering is work less and then get more out of it. I don't know.
Yeah, exactly. Yeah.
Yeah, yeah, yeah.
That's what I
So
tell the kid. Yeah, prepare so that you do it right the first time.
yeah. So this is what we can do. So you can do it by hand or you can use the calculator. All right. So that's how we can do it. All right. Now, so we've been looking at, so we've been comparing marginal cost of $102 versus, 108.8 exact cost. And one of the benefit of having this marginal cost is it gives you the very nice tool to approximate what's about to happen next step, without actually going through the actual calculations. Of course, you may think that these functions are, hey, but these functions are not that complicated. Yes, they're not complicated, but as you can tell, in the real life, in the real circumstances, more real you get, more complicated the functions will be, generally speaking. So that's why you don't want to use the actual function, but you want to use the simplified function. In our case, that simplified function happened to be the derivative. All right. So that's basically what we're doing. Now let's look at the next one. Then our next thing is called not just marginal cost, but marginal average cost. Okay, and then marginal uh, average revenue, and then marginal average profit. So basically, you're just trying to just get the what will be the average cost, and then just getting everything done in that context. So here, average cost function is simply the cost function divided by number of units, of course. Total cost divided by number of units will get you average cost. And then the thing is, if you take the derivative of that, then that becomes the marginal average cost. So essentially, what it does is that uh, what will be what's happening to your average cost if you make one more item at the time. So that's the idea. So let's look at a couple examples here. A small machine shop uh, manufactures a drill bit to use the some this in the industry, and then manager estimates the total daily cost of the production is this one. That's the daily cost. Okay, so we got that one done. Now, so first A, what is the average cost? C bar of X. A C bar of X. That's simply equal to this one, 1000 plus 25 X minus 0.1 X squared. That's what you end up getting. And then we gotta divide that by the number of units, which is equal to X. Okay? So, uh, But next one is we want to get the marginal average cost. But in order for me to get the marginal average, because remember this is a fraction, but wait a minute, my denominator is one monomial. So what I can do is I can divide each term by x. So while this expression is fully acceptable expression for my uh, average cost function, but I'm going to divide each term by x so that it'll be easier for me to find the derivative. Okay, I'm just doing that just for the derivative purposes. So we get 1000 over x and plus 25 because 25x divided by x becomes that, and minus 0.1 x because x squared divided by x gets you just x. And here, since I have a fraction here, I can rewrite this one as 1000 x to the negative 1 power. How about that? And then plus 25 minus 0.1x. So in this way, I get to have my uh, average function, average cost function, simplified in a way that it will be easier for me to find the derivative. Now, let's find the derivative here. C bar prime of x. Then I have to use the power rule. Negative 1 comes to the front, so we have negative 1000. And then x to the what? Negative 2 power. And 25 disappears, and we have minus 0.1 left. That's the derivative, right? Okay, not bad, not bad. But if you're going to rewrite this one, what's going to be happening is negative 1000 over x squared minus 0.1. That's what happened. So my actual average cost will be this function. But what would be my marginal average cost? It is at this point, if I were to produce one more item, what happened to my average cost? It will go down by this much. That's what they're saying. You know? So we're going to be looking at that a bit more concretely in part C. But let's look at part B first, again. Part B. Okay, let's look at part B. Part B is they want you to calculate the C bar of 10 and then C bar prime of 10. So C bar of 10. I'm just going to plug in 10 in place of x's here. So we get 1000 plus 25 times 10 and minus 0.1 times 10 square. Divide whole thing by 10. Okay, but the actual calculation, I'm going to use my calculator. Okay, so that's my value, right? So what I'm going to do is my function, I'm going to put down parentheses because otherwise I cannot combine my uh, numerator into one. So those of you who has 83, so you can just put down the parentheses to designate what the numerators are and what the denominators are. So open parentheses, I would type in 1000. And then what was that? I forgot already. 25x. All right. Oops. Oh, I forgot. By the way, when you type in these things, and if you just like myself, I forgot to type in plus sign. So what some people tend to do is they just delete everything up to that point and they retype everything, but you don't have to. You can actually insert plus sign. You see this is the same for 83 or 84. You see above delete, there's ins. Ins is an insert. In order for it to get to that second, delete. Then you see a small arrow and then comes up. And there you can type in a plus sign. Oops, I put one too many plus sign. Then you can insert a plus sign right there. And then 25x and minus 0.1x squared. And then close parentheses. And divide that by x. I didn't have to put down the parentheses because I only have one term for denominator. So that's one way which you can do. Now, but the thing is, if you have 84, guess what you can do? I'm going to do exactly the same thing one more time. 84 as alpha, type in alpha, y equals. Then it gives you the font because it gives you better look simply. That's it, nothing else. If you press number 1 over here, then guess what? It actually gives you the fraction. So you can kind of type in and then see that you are whatever you're typing is what you originally intended to. So it'll be a bit easier to see. That's it. So now what you can do is you can do 1000 plus 25x minus 0.1 x squared, and then divide by x. Either one would have worked, right? That's what I have. That's And then what I want to do is c bar of 10. C bar of 10. Then since I put it in y sub 1, y vars function 1 open parentheses 10 124. So what's happening is at this point, at this point, it will cost $124 on average to produce 10, I guess, dribblets. I guess, yeah. That's basically what's happening. Now, but let's try to calculate the marginal average cost. Marginal average cost. So what I'm going to do is C prime. So then what I'm going to do here is this. C bar prime of 10. That's negative 1000 divided by what? 10 square x squared, I believe, right? Okay. And minus 0.1. Then you can see that that's 1000 divided by 100. And that's 10, in fact. So negative 10 minus 0.1, which becomes negative 10.1. So that's the marginal average cost. Okay. So we got that, you know. And then if when I get to C, you might things may make sense a bit better. So let's go for C. C is use the result in part B, which we just found out, to estimate the average. So now what I'm going to do is this: instead of following their thing, I'm going to actually try to figure out the actual average cost. Actual average cost uh, when I make 11 bits per day, and I'm going to show you the difference. Okay. So what I'm going to do is I'm going to actually try to get C bar of 11. Then what will I be? What will I be end up getting? So I can do that with the calculator here. Same thing here. So what I'm going to do is I'm going to do vars. Since I've been doing the let me try to just go for this shortcut here. Alpha trace, and it gets you the alpha trace gets you this one right away. Those of you who has 84, and then number 1 and open parenthesis 11. So what this one does is that it gets the average cost per driblet when I make 11 of them. Press enter. Okay. So it got me 114. 114.8. 114.8. But wait a minute. That seems to be pretty close to. Oh, wait a minute. What's happening? C bar C bar of 10 plus C bar prime of 10. What was that equal to? Let me try to calculate this one. So 124 minus 10.1, and that was equal to 113.9. And you can see that they're pretty close. So I'm repeating myself one more time. What does the marginal average cost? Basically, marginal average cost is the impact of producing one more item at the time on its average cost. That's basically what's happening. So uh, C prime of C bar prime of 10 will be, oh, if I produce one more item here, then my average cost will go down by about $10. And that's exactly what I saw here. I mean, they're off by 1.1, but it's only approximation, right? So that's something that which we could have done. Not bad, right? Yeah. So I want you to try to do this question yourself one more time, or by yourself. How about that? And in fact, this will be the end of chapter 9. And you, on Tuesday's exam, you guys are responsible for up to chapter 9. So from whatever we have talked about from Monday all the way till today. Okay?
Professor,
Yeah.
on Tuesday, will we have a recorded lecture to watch, or we're just going to be focusing on the test?
On Tuesday, I'm gonna have a. I thought I'd give you like a little review. So I'm gonna have live review session for the
Okay.
first hour or so. So if you have any questions, you can ask me any questions at the time. And then
Okay.
I'm gonna give you the exam, and then you have 24 hours to do it. Okay?
Okay. Thank you,
All
Professor.
right. You're welcome. So I'm gonna give you about 5 minutes for you to do this question. Okay? Actually, maybe I need to give you about a bit more than 5 minutes. I'll give you about 10 minutes for you to do this one. Alrighty, alrighty. So, how is this one? Was it okay for you to do it? Yeah. So let's try to look at this one together. So, for the first one, A, C bar and then C bar prime. How am I gonna find it? C bar of X is simply this one, 7,000 plus 2X divided by X. Then you can see that this will be equal to 7,000 over X plus 2. Right? That's the expression that we end up getting. But it would be easier if I were to rewrite this one into 7,000 x to the negative 1 power. So in that way, it will give me a nice function for me to, plus 2 by the way, nice function to take the derivative. So c bar prime of x is equal to, here, negative 7,000, because negative sign has to come to the front, and x to the what? Negative 2 power. And plus 2 just disappears. So if I were to rewrite this one, I'd be getting negative 7,000 over x squared. So average marginal cost would be this one. Now, let's look at C bar of 100 and C bar prime of 100. Okay. C bar of 100. Then I'm going to plug in 100 here. So we get 7,000 plus 2 times 100 divided by 100. So then that's equal to 7,200 divided by 100 gets me 72. Okay, that's the C bar. And then, what's the C bar prime of 100? That's equal to this one, so negative 7,000 over 100 squared. Then that's equal to negative 7,000 over 10,000. And that's equal to negative 0.7, in fact. So what would be the average cost if I were to make 100 first headphones? I can approximate that, part C. C bar, C bar of 101, average cost would have been approximately 72 minus 0.7, which is $71.3. So that would be the easy way for you to approximate the average cost. So, so with this one, what we have done was we have gone over the application, in fact, application of increments and differentials. Essentially, that's what we have done. Remember yesterday, the increment can be compared to the what? Exact values, of producing the one more. But the differentials is the can be compared to the marginal cost or marginal of any functions that which we are referring to. So that's the main that's the application of increment versus uh, differentials on exact cost versus a marginal cost. That's the what we can compare them as. All right. So before we continue, we're gonna take about 5 minute break. And meanwhile, I want you to look back on what we have done, and then we're gonna move on to chapter 10. Okay? We're gonna move on to chapter 10. So let's take about 5 minute break. All right. Welcome back, everybody. All righty. I hope that you guys all have great plans for the weekend. You know, or whether it be resting or doing some chores, or working more for some of us, right?
Working more
Whatever that
every
might be.
day.
Yes, that's right. That's right. Catch up with the work, right? Okay. So, uh, all right. Actually, instead of moving on to chapter 10, what I was thinking is maybe I just try to go since today's the last day of our first week, we are already done with 20% of our course. Finishing up the first week. So what I'm going to do is maybe I try to just go over a few homework questions. How about that? If you have any particular homework questions from the chapter 9, you let me know. Otherwise, I'm going to just pick up a few questions from each section, and then we're going to just go over them. Okay? So I'm going to be looking at chapter 9.1. And then homework was 13, 15, 23, 31. So out of that, maybe I just go over a couple questions. 13, 15. Okay, maybe we'll do this one. 13 and 15 is based on this. 13 and 15. These are all based on the sketch that we have. Okay, so let me make this one bigger. So 13 is this, and 15 is this. Okay, so from this picture, I'm looking for the limit of f of x as x approaches 0 from the left. So how do you do that? I'm approaching 0. 0 is right over here from the left. Which value am I approaching? It looks like since each increment is 1, so I'm approaching 2. How about B? If I approach 0 from the right side, oh, same thing, 2. That's good. Then, what is the limit of f of x as x approaches 0? That will be equal to 2 because the same value. And what's the f of 0? F of 0 is what's happening at that value. That's equal to 2 as well. So when all of them are equal to each other, we know that it's continuous. And you can see that visually they're continuous as well. Number 15. We are looking at as limit of f of x as x approaches 2 from the left. If you approach from the left, which number are you approaching? You're approaching 1 here. But if you approach 2 from the right side, you're going for 2. See, 1 and 2, they're not the same. So limit about 2 is DNE, does not exist. And what's f of 2? What is 2 at the time exactly that's happening? Oh, that's right over here. I'm looking for closed circle, not the open circle. Closed circle is right over here, which is 2. So that's what we can do. So being able to analyze the limit graphically, right? That's the first thing that which we talked about. And then 21, 23, 31, same thing. So 20, 30, 31 and 41. Okay. Okay, 41 is nice. So in this case, given that the limit of f of x as x approaches 1 is -5, but g of x, it's approaching 4. So in this case, what do? All you have to do is, I realize that this can be rewritten as limit of 2 f of x as x approaches 1 plus limit of g of x as x approaches 1. I can separate them in two different ways. And then we know that this one is equal to 4, so plus 4. But this one is what? Negative 5, but I have 2 times of that, so we get negative 10, right? Because this is 2 times of negative 5. So ultimately, our answer is negative 6. Relatively simple. You know, that's what we can do. All right. 53. Sixty-one. Let's talk about 61 because we did a piecewise function many times. All right, so 61, when you plug in negative 2, the bottom becomes 0, right? When you plug in negative 2, bottom becomes 0. How about the top? 4. Oh, top and bottom, both of them equal to 0. What do? I get 0 over 0. I try to plug in, I get 0 over 0. So in that case, what I can do is this. In case of A, limit as x approaches negative 2, I can rewrite this one as factored form. So when you factor this one, we get x minus 3, x plus 2 over x plus 2. And you get to realize that, haha, x plus 2 can cancel away, giving me x minus 3. So this one is equal to limit of x minus 3 as x approaches negative 2. So we get, when you plug in negative 2, you get what? Oh, that's equal to negative 2 minus 3. We get negative 5. That's what happens. Now, but B, when you plug in 0, it doesn't become 0 over 0. So in case of B, I could actually just plug in 0. Then 0, 0, we get negative 6 on top, 0 and then positive 2. So we get negative 3. But notice that when I factor and then cancel, I can use either simplified expression or original expression. I get the same answer. You know. How about 3? When you plug in 3. When you plug in 3, your numerator will be equal to 0. Okay, numerator will be equal to 0, but denominator will be equal to 5. So what's 0 over 5? 0 over 5 is equal to 0. So that's what I can do. All right, so that was kind of section 9.1. Now 9.2, had a couple set of questions. 9 through 21 odd. 9 through 21 odd. All right. By the way, you can submit your homework by Sunday on the Google form that I submitted for you. It's on the my task section. 9 through 21 odd. Okay. Okay. Maybe I'll do number 17 first. So in case of 17, limit of f of x as x approaches 5 from the left. 5 from the left That means x is in fact less than 5, isn't it? So I can do this one two ways. I can either sketch it and figure things out by looking at it, or I can plug in the numbers and then to see which one works, or to figure out what value it approaches. So what I can do is this. I'm gonna put this one into my function. On the calculator, x over x minus 5. X divided by, I need to put the parentheses because I have binomial, more than one term on the denominator. So I need to put the parentheses to group them together. X minus 5. Okay? Now, the value that I'm looking at is about 5. So what I'm going to do is I'm going to zoom it. Zoom standard. When I do zoom standard, then it gets me negative 10 to positive 10, negative 10 to positive 10 on XY window. So I'm going to Z standard, zoom standard, number 6. And that's the picture. So one way which you can tell is by looking at the picture and then where is 5? 1, 2, 3, 4, 5. Oh, right around there. Where I have green dotted line, that's where the 5 is at. So one way that I can do this, since x is less than 5, which direction is it approaching? Oh, it's going down. So my answer will be what? Negative infinity. Right? But here, I'm coming from the right side. Which value is it approaching? Oh, positive infinity. And these are the representation of the vertical asymptote, right? As x approaches some sort of a constant, either from the left or right. And then, but yet the function is approaching infinity. That's the limit definition of vertical asymptote. But since, whatever they're approaching, but they're not equal to each other, so therefore, our limit is dne. And you can use the calculator to do it this way. Another way for you to do it is by plugging in the numbers. I'm approaching 5, but x has to be less than 5. So let me try to show you that a little bit using the calculator. Now, normally, if I have to go for table of value, not this one. Let me just change this one a little bit. If you get to the table of values, then this is what you see. You cannot control the numbers, but in fact, you could control the numbers through this way. You can control the table input values in this way. So right now, what I'm showing you is a typical ways for you to see that table of values. But guess what? Do you see table set? This is true for TI-83 and TI-84, both of them. The table set right over here, I can access that by second window. So this one is the setup or settings for my tables. And then you will see when you go down here, you see independent. Independent is basically X values. So right now it's all automatic, auto. So your calculator will automatically generate the X values, and then therefore dependent automatically will generate the Y values as well. That's what they do. But if you go from the order to ask, so instead of here, you go to the right, right? Right now, you know that auto and auto, you see auto and auto, they are highlighted. But if you press enter when it's clicking or blinking, guess what? Now, then you just change the independent variable as ask, meaning x value is ask. So then what your calculator will do is your calculator will ask you the input values. Okay? And let's see what we end up getting. It's blank. Why? Because your calculator is waiting for you to ask questions. So I'm going to input the values close to 5. And as I'm approaching 5, I'm going to observe with the values what kind of y values is it approaching. So in that way, I can kind of make a guesstimate on what the limit should be equal to. Because after all, limit is where the function is approaching, but not uh, actually at that value, right? So what I can do is I'm going to type in 4 and try to look at the y value. Oh, it's negative 4. Okay, let me try to get closer. 4.9. Oh, negative 49. Let me get to closer to 5. So 4.99. Because remember, I cannot. Oh, negative 499. Remember, I cannot be at 5. I just have to be close to 5, right? So what I'm doing is from 4, I'm going closer to 5 right now. 4.9999. 9. Why not? Oh. So what do you realize, guys? Values are getting bigger and bigger, but it's negative. So by looking at this pattern, you can see that my y value is approaching negative infinity because it keeps on going down. Just like how I've seen it from the graphically, I can see the same concept numerically. Now, if I were to go from the right to left, so I'm trying to evaluate this one. How am I going to do that? I'm approaching 5 from the right side. So then maybe I can start from something greater than 5. So maybe 6. Oh, I guess 6. But let me go for 5.1. That's much closer to 5 now, isn't it? Oh, 51. What if I were to go for 5 point, not 1, 1, but 0, 1? Then I'm much closer to 5, right? Ah, 501. Well, what's happening? The value is getting bigger. What if I were to say 5.00000 instead of 1, maybe 2? I don't know. At least it's smaller than this one, right? Oh, then this is scientific notation. 2.5 times 10 to the 6th power. So it's that much bigger. So you can visually, you can numerically see that we are approaching infinity here in this case. So that was number 17. All right, guys. Other questions? 55, 57, maybe. We'll see.
No questions. No questions. All
Yes.
good.
All right. Sounds good. 50. 5. Okay. What I'm going to do is 55 first. 55 is the one of the questions that I gave you. Okay. So in this case, the question is to find the horizontal and vertical asymptote. That was the question. Hmm. So you can do this one graphically using the calculator. That's perfectly fine. Or another way which you can do this using the limit to justify those limits. So how do I know if there's a whatchamacallit? So let me try to look at this one first. To find the horizontal asymptote, how do you find the horizontal asymptote? I need to test for two things. Limit of the function x cubed over x squared plus 6 as x approaches infinity. positive infinity, right? Then wait a minute, guys. Remember we talked about the orders of the functions? X cubed versus x squared. Which one is bigger? Of course, x cubed is much bigger, isn't it? Top is much heavier. So therefore, in this case, since top is much heavier, this will be approaching positive infinity. Then do I have horizontal asymptote? No, I don't have horizontal asymptote here. Let me try to go for the left side, see what happens. X cubed over x squared plus 6. In this case, top is still heavier, so it's going to be some sort of an infinity. But when you look at it, my top is negative because negative to the third power will still be equal to negative. The bottom one, negative squared, it becomes positive. Negative over positive, what do we get? We get negative. So negative infinity. Still no horizontal asymptote. Nothing happened. But how about the denominator? Can you ever have x squared plus 6 ever be equal to 0? Because that's where we're looking at. And you realize that x squared plus 6 can never be equal to 0 because when you subtract 6, how can you have x squared to be equal to negative 6? Square number cannot be equal to negative. So therefore, there's no vertical asymptote. All right, we got that. We got that. But another example that I can give you would have been something like this. Let me give you number 52. This one wasn't part of your homework question, but I thought it was kind of nice. Do you think you can try to find horizontal asymptote and vertical asymptote? And then the thing is, we need to justify that, right? All right. So I want you to try to give me the horizontal and vertical asymptote on this function. Let me just give you 5 minutes. Alrighty. So in this case, how would you be able to do it? I mean, the one easy way which you can do it is you can sketch the graph and then what you call it out justify through the limit. For example, what I'm going to do is this. I'm going to use the Desmos, our lovely friend Desmos. Okay. If you get to Desmos, graphing calculator, and then what I'm going to do is I'm going to type in the function. The function was 3x plus 2 and then x minus 4. Y equals parenthesis 3x plus 4 divided by x minus, what is that, x minus 2? X minus, 3 minus 3x plus, I got the wrong number, plus 2x minus 4. So I get something like this, and then it's kind of difficult for me to see. I'm going to zoom out a little bit. Oh, okay, there it goes. It seems like I do have one vertical asymptote and one horizontal asymptote. Oh, actually, I didn't. Whoops, I didn't share the screen with you. Oh, yeah. So when you look at this picture, you can see that we have a one vertical asymptote and one horizontal asymptote, right? Then we're gonna justify that. How? To establish horizontal asymptote, I'm gonna be doing limit of 3x plus 2 over x minus 4 as x approaches infinity. Now, if you think about it, as x approaches infinity, plus 2 or plus 2 or minus 4, does that is that significant? No, not really. It's very minor. So what I can do is I can say that hey, this can be expressed as limit of 3x over x as x approaches infinity, because these two numbers are so insignificant. Imagine, you won the lottery somehow, and then you end up having $1 billion, not even million, billion, $1 billion, and then somebody has, hey, I'm gonna give you $2 more, or hey, I'm gonna subtract $4. It doesn't. It's so insignificant compared to 1 billion, right? So we can approximate this one into this way. But when you look at it, we have 3x over x, 3 to 1 ratio. So this one simplifies into what? Simply 3. So that tells us that y equals 3 is our horizontal asymptote. And in fact, you can see that right away. From the Desmos, I can type in y equals 3. And you can see that that blue line is the horizontal asymptote where the function is approaching. All right, how about the next one? We're looking at the vertical asymptote. And obviously that's when denominator is equal to 0, which is 4. So the vertical asymptote, you can say that as limit of 3x plus 2 over x minus 4. Let me just say x is approaching 4. It can be either from the left or right. So let me call that as left. Then which value is this approaching? When I approach 4 from the left, you can see that my graph is going down. So therefore, I know that my answer for this one should be negative infinity. Therefore, my vertical asymptote is x equals what? 4. So I can justify my horizontal and vertical asymptotes using the limit. So questions like these were part of your homework actually. And then if I were to just move on to section 9.3, okay, 9.3. Questions that I can look at. 4751. Oh, 47, actually, 47 and 51, you can skip it for now. 53, 55. Oh, these are all inequalities. Actually, we skipped this section, so you don't have to worry about the inequalities actually for now. I'm going to bring that up later. Okay. So questions like number 69 is important. All right. They want you to locate the discontinuity if there were to be any, right? So since when x is less than 1, we have a simply linear function. When x is greater than 1, we have another linear function. So we don't have to worry about any discontinuity within that sections. Only thing that which we have to worry about is when x equals 1. So in order for me to check for the discontinuity, I'm going to find the limit and then compare to that. I'll be basically checking up on this one. Continuity is what? Limit of the function as x approaches a has to be equal to f of a. So that's what we have to know. Then, in this case, a is equal to 1, so I'll be looking at limit as x approaches 1 from the left. That means x is less than 1, so we have to look at the first expression, 1 plus x. That has to be equal to the limit as x approaches 1 from the right, meaning 5 minus x. In that case, what happened? When I plug in 1, I get 1 plus 1. Is that in fact equal to 5 minus 1? This is 2 and that's 4, and you get to realize that they're not equal to each other. So therefore, we get to realize the limit of f of x as x approaches 1 does not exist. Because they are approaching two different values. One is approaching 2, the other one is approaching 4. So then what kind of discontinuity we have? We have something called jump discontinuity. Right, we have jump discontinuity because there was a jump. They're approaching two different values. All right? And then, of course, it's not continuous because the limit doesn't even exist. All right. And so that's the highlight that I wanted to share with you. And maybe number section 9.4, that's the derivative. And then the questions were 15, 23, 33. 23, 33. Okay. So what if I were to move on to 23 for a second? And in this question, they want you to find the derivative using the limit definition. So how do you find the f prime using the limit definition? It's the limit 2 minus 3, and in place of x, we're going to place x plus h square minus the original function as it is, 2 minus 3x squared over h as h approaching 0. Right, that's basically what we can do. Now, then when you square x plus h, note that x plus h squared is equal to x squared plus 2xh plus h squared. That's what we end up getting. So what we can do is I can rewrite this one as limit 2 minus 3 times of that, so minus 3x squared, minus 6xh because I multiplied this one by negative 3, and minus 3h squared, and minus 2 because of this negative sign is being distributed, plus 3x squared. It's pretty long, but all right. And over h as h approaching 0. Then you get to realize that here, negative 2 and positive 2 cancels away, and then 3x squared cancels away. Then what we have right now is the limit of 6xh minus 3h squared all over h as h approaching 0. Then h can divide 6xh with h's, so we are left with limit of negative 6x from the first one. And then these h's cancel away, so we have minus 3h as h approaching 0. But since h is approaching 0, this one will disappear, and we are left with negative 6x. That's the derivative of the. And then you can see that they would have been correct, and you know the answer already using the power rule, but you should be able to use the limit definition. Okay? And that was one thing that which we have to do. And after that is the things that we have talked about, which was using the power rule, which we've been doing a lot these days, and marginal, increments and marginal, so practices that we've been doing just now. So I'm hoping that these quick review on the homeworks were a little bit helpful, and then these are basically what you guys have to work on for your exam. All right. So with that, actually, I'm gonna finish up for today. Today, I'm gonna finish up a little bit early. All right. And then have a great weekend, everybody, and I'll see you on Monday. All right. Monday, we're gonna start from chapter 10.
Okay.
Bye, everybody.
Have a good night.
Good night,
Thanks. Have a
Professor.
good weekend.
Good night.